The plane pi1 contains the points P, 3, negative 1, 4, Q, negative 2, 0, 6, and R, 2, 4, 8. In A part 1, we want to find the vector PQ and the vector PR. So, well, PQ is equal to Q take away P, which is negative 2, 0, 6, take away 3, negative 1, 4. And so that gives us negative 5, 1, and 2. PR is equal to R take away P. So that would be 2, 4, 8, take away 3, negative 1, 4. And so that gives us negative 1, 5, and 4. Hence find the equation of pi1, the first plane, expressing your answer in the form ax plus by plus cz is d, or Cartesian form, where a, b, c, and d are integers. So we want a vector that's perpendicular to those two vectors. Those two vectors are vectors in the plane. We want the normal, and we do the cross product to get a vector which is perpendicular to the first two. So we've got I, j, k, negative 5, 1, 2, negative 1, 5, 4. And so if we cover up the I and the top row, we get 1 times 4, which is 4, take away 5 times 2, so 4 take away 10, gives me negative 6. Covering up the j, lost the k when I did that, covering up the j gives us negative 20, take away negative 2, negative 20, add 2 is negative 18, but we always change the sign for the middle one. So that's going to be positive 18. And then covering up the k is going to give me negative 25, and effectively add 1, which is negative 24. And rather than use that vector, I'm going to divide everything here by negative 6 and use 1, negative 3, 4. Okay, so R dot 1, negative 3, 4 is going to be equal to, we can use any of the points we know is in the plane, so I'll just use P. So that will be 3, negative 1, 4 dot 1, negative 3, 4. So it's just R dot n equals A dot n. And so that gives me R dot 1, negative 3, 4 is equal to 3 plus 3 plus 16, which is 22. And then we can turn that into Cartesian form just using this vector as the coefficients. So x minus 3y plus 4z is equal to 22. Okay, the plane pi2 has equation 5x minus 2y plus 7z equals 12. Find the acute angle between the normal vectors of planes pi1 and pi2. We may use the fact that root 26 times 78 is root 2028, which is root 676 times 3, which is 26 root 3, without any proof. Okay, so N1 we know was 1, negative 3, 4. N2 was 5, negative 2, 7. Now, we know that A dot B is mod A mod B cos theta. So here we can say, well, cos theta is going to be 1, negative 3, 4, dot 5, negative 2, 7, divided by the square root of 1 plus 9 plus 16, which is 26, and then the square root of 25 plus 4 plus 49, which is 78. Okay, so that is equal to 5 plus 6 plus 28 over root 2028, which is 39 on 26 root 3. Okay, so that is 3 over 2 root 3, dividing top and bottom by 13, which is root 3 on 2. And the cosine of theta is root 3 on 2. Theta is 30 degrees. The plane pi 3 has equation 2x plus y plus z is 10. Planes pi 1 and pi 3 intersect in a line L. Find a vector equation for L in the form r equals mno, or is that a 0, plus lambda pqs, where m, n, p, q, and s are rational numbers. Yeah, it looks to me like that one is a 0. Okay, so we have this plane and also x minus 3y plus 4z equals 22. Line needs to be perpendicular to both planes. And that means we're going to do another cross product. So we've got 1, negative 3, 4, 2, 1, 1. I'm not going to step all the way through this one. It turns out as negative 7, 7, 7. So I am going to use negative 1, 1, 1. We need a point on both planes, because that point must be on the line of intersection. And a way of doing this is just take one of the components to be 0. I'm going to take z is 0, and then we get x minus 3y equals 22. That's just having z equals 0 in here. And we get 2x plus y is equal to 10. If I multiply that one by 3, it would give me 6x plus 3y equals 30. And so, just adding those gets rid of the y's. We get 7x equals 52. So x is equal to 52 over 7. Substituting back, probably which one would be the easiest? The 2x plus y equals 10 is probably the easiest to work with. And substituting back would give me y is negative 34 over 7. And so r is equal to 52 over 7, negative 34 on 7, 0, plus lambda negative 1, 1, 1. Obviously, this bit is not unique. Any point on the plane will do. So it may be that you get a different answer, but it is still the same line.